Let's revisit specificity and sensitivity and see how it is calculated. In the language of hypothesis testing, we can have the classification problem expressed as a hypothesis 1 or class 1 and hypothesis 2 as class 2. Often one of the hypotheses is called the null hypothesis and the other the alternate hypothesis. In our example, we can say hypothesis 1 as the person is B and hypothesis 2 as the person is F. This is the case of a binary classifier. Now recall, we had two kinds of errors defined, the type 1 error and the type 2 error. The type 2 error is the one minus the specificity. The model inherently classifies between the two classes or hypotheses by making a cut or a threshold. In this case, let's put the threshold as 0.5. With this cut, we can calculate the area under the probability distribution of both the hypotheses. If the type 1 error for a given cut or test statistic for a given hypothesis is less than a predetermined value called significance, which is expressed as a probability of the classifier, we fail to reject that class. We also claim that as failing to reject the null hypothesis. We also define the power of the test as 1 minus the sensitivity or the type 2 error. Now notice the sensitivity and the specificity is dependent on the threshold or the cut determined here. If we move this around, the values for sensitivity and specificity will change. You can guess now that we can draw a curve that plots the specificity versus sensitivity for different values of this cut. Such a curve is called a receiver operator characteristic curve. In the following video, we will look at an ROC curve for our classifiers.